So on these voting problems, to kind of finish out this section, they work a little bit differently. We're not gonna we don't have that ranking that we've had before to decide how many pairwise points or border points someone has. Instead, we're going to be kind of finding a missing one. So this is really to make sure you understand how pairwise and border work. So kind of upping the ante, a little bit harder conceptual problem. So we'll start right up here. We're going to be dealing with the pairwise comparison. So in this one, we've got 1, 2, 3, 4, 5, 6, 7. 7 candidates that are running for office. And I've told you how many pairwise points they won, except for this very last one. We need to figure out how many candidate G got. So to do that, I'm going to add up all these that I know. I don't know the last one, so I'm going to put a question mark, or you could put an X there if you would rather it look like an algebra problem. And this is going to be equal to the total number of pairs. Now, I'm going to have to do a little bit of work to find the total number of pairs. There are quite a few ways to do this. My math lab's actually going to have you do a formula, which you are more than welcome to memorize the formula for. I'm not going to give it to you on the test because you don't really need the formula, but you can totally use it. There's nothing wrong with using that. I'm going to just show you our alternate method. So you've got my math lab showing you the one formula way, and then you've got me showing you another way. So you've got these two different methods that you can use. It's always good to have those options. So my way to figure out the total number is it's a pattern, and I like patterns better than I like formulas. So this is my go-to, but there's nothing wrong with the formula way either. Everybody is different. So to find these total number of pairs, I'm going to kind of show you how the formula works to start with, how the pattern works to start with. And then you won't have to do all this work every time. A is going to get paired with every one of these other candidates. So A got paired with 1, 2, 3, 4, 5, 6. So it got paired with 6 of them. Then B is going to get paired with everybody below it. B doesn't need to get paired with A because it already has been paired with A. So that's 5. Then C is going to get paired with everybody less than it. So that's 4. And then D, that's 3. So you kind of see that pattern where it's decreasing by 1 each time. That was the pattern, not like a crazy, super cool pattern. And then the last one is just F and G. So there were 7 candidates. It's always going to start off like this one's going to start off with 6, 1 less than that, because A can't pair with A. A can only pair with everything less than that. So the number of pairs are 6 plus 5 plus 4 plus 3 plus 2 plus 1. So we're just going to add all those up together. And that gives us 21. So up here, I can replace my total number of pairs with 21. Hardest part done. I'm going to add up all these numbers right here that I know. They are all like terms because they're all plain numbers. Adding them up gives me 20. You might can just look at it and know what the question mark is. Maybe you'll get one that is harder to know than just looking at it. This one's pretty straightforward. So to solve, we would subtract. So the question mark is 1. The missing number of pairwise points is 1. Now, if you don't like that question mark, remember you can change it to an X. B is the easiest part, even if you do not know how to do A when it comes down for a test or a classroom assignment or something. Just on B here, we'll look, the winner is the one with the highest. So B wins with 6 points. All right. We're going to do another one of these. This one's going to work different because I'm going to use Borda this time. Sometimes people want to know why I'm doing it differently on these. Just make sure one's using pairwise, one is using Borda. But the general idea is going to be the same. I'm going to add all of these guys up. This time the missing one was the first one. And that's going to be equal to the total number of border points. So now all I have to do is find the total number of border points, just like I found the total number of pairwise. So to come down here and find that total, remember border is kind of like that formula. And I have to tell you on this one the number of voters. If I don't tell you that, you can't work the problem. So I won't give you one like that. So we have to tell you the total number of voters. So there were 20 voters. And remember, they're going to be first place, second place, third place votes on that one. So remember, it is, let's see, 1, 2, 3, 4, 5 candidates. So 5 minus first place, 5 minus second place, 5 minus third place, 5 minus fourth place, and 5 minus fifth place. Couple different ways you can type all that in. You can type it in just like that. We've talked about this when we did our bordas. You can reduce it down to start with if you want to. But however you're going to type that in, you're going to get the total is 200. So my total number of border points is 200. Last step's easiest. We've already done the hard step, figuring out that 200. I'm going to add up all those like terms up there at the top. I don't know what the question mark is. Adding up all those like terms gives me 170. I've got to solve, or maybe you know in your head, for the question mark. The question mark is equal to 30. So that missing number up there, the number of border points for A was 30. Part B is the easiest one. It's the winner. The winner's the highest one. So E wins. I'm going to go ahead and say with 55 border points.